In my video on data and data types, we looked at the different types of data. One of those was categorical data. In this video, we'll look at displaying categorical data, which falls under the organizing and displaying data step in the statistical investigation process. In this video, we'll look at a reminder of what categorical variables and data, or nominal data and ordinal data are. We'll look at ways to display categorical data, including a tally and frequency table, a dot plot, a column graph, bar graph, and a pie graph. Categorical variables describe a particular quality or characteristic. Data is divided or grouped into categories, and the information collected is called categorical data. Categories can be either nominal, which is data that has no inherent order or ranking or sequence, such as names and classes. Examples are colors and gender. The value may be numerical, but without numerical value or mathematical meaning. For example, you might use the number 1 to indicate male, and number 2 to indicate female, but that has no mathematical meaning. Ordinal data is data that has inherent rank or order. Mild, moderate, severe are examples. It can be compared for equality or greater than or less than, but not how much greater than or less than. Medical research aims to improve the health and well-being of people. It draws on our knowledge of the human body and the world around us to find ways to identify, cure and prevent disease, reduce injury and disability, and improve the delivery of health services. A medical research organisation was investigating the link between eye colour and disease. They surveyed research participants and asked what colour eyes they have. What are some of the ways that we can summarise this data? We're going to look at a few of those now. So the medical research organisation collected the eye colour information from a sample of their patients and recorded the data in a tally and frequency table. A tally and frequency table, sometimes referred to as a summary table, includes a tally column, a frequency column, and sometimes a percentage frequency column where the rows are the categories. In our example here, the rows are the colours of the patient's eyes. A tally is a tool used for counting as the results are gathered. Numbers are written as vertical lines or bars, with every fifth number having a strike through a group of 4 bars. For example, 4 is 4 bars, and you can see that in our green eye colour there. Or 7 is 4 bars with a strike through plus an additional 2 bars. Frequency column shows how common a certain value occurs. So you'll notice here in the brown we have 5 plus 5 plus 1, which is 11. So there's people with brown eyes, there's a frequency of 11. The percentage frequency shows the percent that an item came up compared with the total number of results. So the total number of people surveyed is 27, and that can be identified by the total in the frequency column. And the way we work out percentage frequency is we say 11 divided by 27, or 11 over 27 is a fraction, because we had 11 people with brown eyes, and there's 27 people in total, so we can put that into our calculator, and it is approximately 0.39. And to turn that into a percentage, we times it by 100, so we get 39% of people had brown eyes. Likewise, blue eyes, there was 10 people with blue eyes, and we have 27 people in total, so we have 10 on 27 as a fraction, which is approximately 0.36. And we turn that into a percentage, we times by 100, and we get percentage of people with blue eyes is 36%. One of the first graphs you might have learnt to draw is a dot plot. A dot plot is a column. In a dot plot, a column represents each category. The number of dots represents the frequency values falling into a category. A dot plot is made up of dots plotted on a graph. Each dot represents a specific number of observations from that data set. The dots are stacked in a column over a category so that the height of the column represents the relative or absolute frequency of the observations in the category. The pattern of the data in the dot plot can be described in terms of symmetry or skewness only if the categories are numerical. In this case, we've got categorical data, and therefore we can't describe the symmetry or the skewness of this. Dot plots are used most often to plot frequency counts within a small number of categories. Here we only have 5 categories. We've got the colour of the eyes, and we've plotted with dots to represent how many, or the frequency of the eye colour in the survey. With a dot plot, we can easily identify the mode of the data. In this case, you can easily identify that the brown eyes is is the mode because brown is the category that occurs the most often. And that's really easy to see on a dot plot. In a column graph, a column shows each category, the height of which represents the amount, frequency, or percentage of values falling into a category. This is actually a column graph. It's what we call a dual axis column graph because we are showing on the same graph the percentage frequency and the frequency. So we have the axis on the left and on the right with numbers along it. Important thing to note is because the categories are not continuous, so we don't have continuous numerical data here, columns do not touch each other. This is a key error that people make often. In a column graph, which is a type of bar graph, we use vertical bars to display the data. They have 4 parts. You've got to make sure you have the title in your charts. You've got to show the labels, what's displayed on each axis. And scales are the numbers that show the units being used in the graph. The scale numbers increase from the bottom to the top on your vertical axis. And on the left to right, in this case, we're looking at categorical data, so there is no order. In a bar graph, a bar shows each category, the length of which represents the amount, frequency or percentage of values falling into a category. It's exactly the same as a column graph. However, a column graph has limited space in the category axis along the bottom. So when your data labels are long, in this case they're not too long because we've got the color of the eyes, the category axis may look cluttered. So if those categories were long names, it would look very cluttered to have them in the horizontal axis. In this case, we turn the graph on its side, which turns it into a bar graph. That's how you reduce the clutter of a graph when you've got large names. Pie graph is a circle broken up into slices that represent categories. The size of each slice of pie varies according to the percentage of the category. In this case, it's important to note that we're using the percentage of each category. So the size of each piece of the pie varies according to the percentage. So we're using the percentage column in our percentage frequency table. Up until now, we've been looking at nominal categorical data, displays and graphs. When we graph ordinal data, the most important thing we need to do is remember to maintain the order of the categories. Remember that ordinal data is data which has an inherent rank or order. Here we have kept the data in order, so we've got strongly agree, agree, neither agree nor disagree, disagree, strongly agree. That follows a logical order. This helps us understand the data better. In this case, you can clearly notice from the columns that more people agree than disagree. And that's why it's important to keep the columns in line. So in summary, we've looked at revising what categorical data is, including nominal data and ordinal data. And then we've looked at categorical data displays, including tally and frequency tables, dot plots, column graphs, pie graphs, and bar graphs. Thank you.